While mathematics is the language of the universe, it's what we use to describe the very large or the very small, and we use quantum mechanics to describe the very small, and then we use general relativity to describe the very big, which is the whole of the universe and how it works. And all these subjects are actually described in mathematical terms. So mathematics brings about order to this chaos. I became interested in mathematics. I think it was when I was doing Maths Olympiad. I think I loved the process very much because you're never going to put numbers into an equation and then it magically gives you the answers. There was this thinking process behind it. You had to think, what does the question ask of you? And then you had to go about your own thinking and your own manipulation to solve the problem. Mathematics is one of the most beautiful things that I think I've ever seen, because a very good example I might come up with is the Fibonacci numbers, which also relates to the number of petals on a flower. The idea that nature knows what maths is and maths knows what nature is, and then these two kind of things combined, and then it's all about conveying the idea that there's a continuation or a pattern behind it. Well, I think the most interesting thing about mathematics is that it has so many applications. For example, if we are talking about how spaceships fly in space, or how we communicate with our friends from a very large distance, or how electricity even works. And mathematics comes and then it brings to light what was hidden in the dark, because it will tell you why it works or why it doesn't work, and how it comes with the ideas to make it work. And I think that's one of the most powerful ideals of mathematics. It's all about patience in mathematics. There is no way you're going to be given stuff and then you understand them. You have to sit down and think, what does the equation mean? Or what is the message it wants to convey? And if you go about that, because sometimes an equation does not make sense at first sight, because it is not of second nature to you, but if you continuously do it, it will come naturally. One of the most interesting topics in mathematics is differential geometry, because its derivation came from geometry, Euclidean geometry, but then we have to consider that what about surfaces that are curved, or the manifolds or the curves of surfaces. And then one of the most interesting things about differential geometry is that the mappings, it can take a 3D object and then it can map it onto a 2D object. For example, how the atlas looks, we use differential geometry to map the spherical picture of the earth into a 2D plane. I think one of the most inspirational people in mathematics is Leonard Euler. The man was practically a genius because he made so many contributions in mathematics and physics. For example, if we are talking about mathematical analysis, or we are talking about mechanics or fluid dynamics, I think he's the foundation of the maths we are doing now. I think my favorite equation is Leonard Euler's identity. It states that e to the power of I times pi, and then we add 1 to it, gives us 0, where e is Euler's number, and then we've got I, which is the imaginary unit. Then we've got pi, which describes the ratio of a circle to its diameter. And then the most interesting thing about this equation is that it includes geometry and trigonometry and other parts of mathematics, and then it combines it into this small equation, but it describes so much. I think first and the most important thing in mathematics to understand is get the idea. What is the equation trying to say, or what does the message it wants to convey? If you go about that, and then given any problem of some sort, attack it from that angle. And then you say, if I give you a problem in calculus, attack it from a calculus point of view. you.